So our first speaker for the afternoon is going to be Rocky Freund with the Oasis River Authority, and she's going to talk about bacteria indicator study that they did on Arroyo, Colorado.
Okay, good afternoon, everybody. Please continue. I know bacteria is not the best source of that's what we'll be talking about during lunch, but oh well, here we go. I'd like to acknowledge Texas Commission on Environmental Quality for funding this project, and also, of course, I did not put in the slide acknowledging Beth Almaraz and Sam Shigeric with our office, who actually are the ones that went out and did this sampling. Okay, the project area, we were in the Oasis Rio Grande Coastal Basin, and the study was done on the 63-mile segment of the Arroyo, Colorado. It's the above tidal segment of the Arroyo, Colorado. And for TCEQ assessment purposes, it is split into 4 assessment units. Okay, just a little bit of background. The above tidal portion of Arroyo, Colorado was first listed on the 303 list for bacteria in 1996. In 1998, the Arroyo, Colorado Watershed Partnership had been formed more in response to the study of a dissolved oxygen TNDL that had been going on the tidal portion of the Arroyo, Colorado. But the results of that showed that they really needed a whole watershed approach, and not just a TNDL or DO. And so the partnership was formed and had been doing a lot of work in the watershed. And in 1999, for those of y'all that remember the sampling, is when we switched from collecting and analyzing fecal coliform to E. coli. Of course, there was a little bit of overlap where we were collecting both until there was enough samples to get to do an analysis using E. coli. So, the 2006 assessment, they looked at both. The assessor looked at both fecal coliform data and E. coli. And for all 4 assessment units, fecal coliform GME exceeded the standard of 200. However, for 2 of the assessment units, and these are the most upstream part, most upstream assessment units, 2 of those, the geometric mean was below the 126, and it remained on the 303D list. Ann Rogers was the assessor, using her best professional judgment. She said, "Now I'm going to leave it on the list based on the older fecal coliform data." So it got me thinking, like, okay. We're switching bacteria types, and we have an overlap of the data. So, we've got fecal coliform up to a certain point, and E. coli. So I'm wondering, are the bacteria levels really getting less? Is the work that the partnership been doing been paying off? And if we had continued with fecal data, would we have seen a drop off? Or would the high specific conductance values that we were getting, which were up about around the 3,000 range, where was affecting E. coli? Was E. coli dying off, and therefore would the taro actually be the better indicator bacteria? So we asked TCEQ to help fund this project, and we collected data at 6 sites during calendar year 2009. And I want to back up for just a second to those questions that I had listed on the previous slide. This study did not intend to answer those questions per se, but just to kind of get a background information and start the thought process on whether we should actually look into this. So we collected again monthly, and we analyzed for all 3 of the indicator bacteria. And these are the 6 sites. Starting up here, and all the information I'm going to show you is from upstream to downstream. So we have these 6 sites, and I don't have the assessment units blocked on here, but it did cover there was at least 1 station in each of the assessment units. Okay, now on these slides, I thought mine were complicated. Some of the ones I saw, these are pretty simple. But what I'm showing here, for example, on the this is the data. The lower limit of the line graph is the minimum value that we collected during the 12 samples, the max value. And then what I did, I kind of cheated on these bars. The lower limit here is, in this case, the geometric mean of 200. The upper part of that bar is the calculated geometric mean based on these 12 samples. I know they're not statistically enough samples to do a whole lot with, but this is the raw data that we use down here. This, again, the 6 sites, the sampling, the days we sampled, and then the geometric mean down here in this last column based on the raw data. All the ones in yellow in here exceeded the graph sample standard. And then the yellow in the geometric mean column means it exceeded the standard. So this is what the data looks like for the coliform. And again, this is upstream to downstream. You see the values. And on all the graphs I'm going to show you, I'm using the same y-axis just for comparison purposes. So that was the fecal information. E. coli, again, these are adjusted for, this is 126 on the bottom, what the measured geometric mean is. And you can see, again, there was a lot fewer graph samples that exceeded, but all the geometric means exceeded. So regardless, this would have been listed for E. coli for geometric mean, just using this data. And the Entero data. Again, almost all samples exceeded the criteria. But and one thing, just to point out, you can see on the Entero how the width of these bars, the thickness of these bars, kind of shows how far above the geometric mean these exceeded. So I'm going to flip back. Those are relatively thick. Oops. E. coli is a little bit thinner, and fecal were much higher than the geometric mean. So the observations, going back to the questions that we asked at first. Well, here's all the. Oops, I'm sorry. There we go. Okay. With the 2006-2008 assessment data, the one that did change and what the geometric means had been calculated at. Then there's the data for the range, and the range is for each of the assessment units, so it consists of the 4 numbers. And then the 2010 assessment for fecal. Well, you might be able to argue that it's coming down a little bit, but was that because we weren't collecting for fecal anymore at the higher values? It was going down, and the higher values in the early part keep dropping off. Really don't know. And the data taken in 2009 was not included in the 10 assessment, because this 10 assessment data, I believe, ended in November of 2008. And then the same type of information for E. coli. Maybe there might be a little bit of reduction. Maybe the lower end is a little bit higher, the higher end is a little bit lower, the 2010 assessment. And then just for comparison purposes, put up the Enterococcus information too. And just, the Arroyo, Colorado, that partnership, they've been doing a tremendous amount of work down in the valley. And it would be hard to imagine that everything that's being done is not having some effect, but really don't have, with this study, do not have the quantitative data to say that or not. And then the question, is it being affected by the specific conductance levels? Well, this is again the range that we measured during the sampling events, and according to a USGS publication, we're definitely in the brackish water category. So salinities and the specific conductance are a little bit higher than you would normally think for a freshwater stream. And so, would Enterococcus be a better indicator bacteria? I don't know. But if you look at these 3 charts, just don't, the numbers, I'm not expecting you to read all the numbers, but just a quick visual, Enterococcus a lot more closely resembles what we were seeing with the fecal data than with the E. coli. And just, based on very limited data, if we continue to see this trend, sorry Alice, 12 points is not a trend, with E. coli going down, then E. coli may hit this, meet the standards a lot sooner than enterococcus. So for public health reasons, do we want to change it? Nobody wants anything to be on the 303B list. But if we're going to take something off, it needs to be because it is meeting the standards and make it safe for recreation. And I did want to point out, Katie, also with my office, Katie Carberry, and Sam and Beth have recently completed an RUAA that was done on Arroyo, Colorado. They did document contact recreation, so I think it's fairly safe to say standards are not going to change for down there based on an RUAA, and the sentiment in the valley is they do not want the standard to change. So I had very brief. Again, it was just pretty much a study to kind of get the thought process started. This information has been supplied to TCEQ. I don't think we've looked at actually changing the criteria on that segment, but again, it's just the very start of the process. And that's all I have. Anybody have any questions? Yes.
For the E-coli, was he using a membrane filter or
what did the lab? It was analyzed at A&M Corpus Christi lab, and I believe they use IPEX method. Yeah, Sam and Beth are shaking their head, yes, IPEX. Anybody else?
The new standards that were approved that have the high saline inland waters, what's that threshold? You know that, or?
I don't know what that threshold is. Alan, anybody else?
I think it's 9,000.
9,000.
So can you go back to your connectivity slide? So you're not quite there yet.
Well, yeah, we're in the brackets. But yes.
I just like to make an observation that the Arroyo, Colorado seems to be an ideal watershed to look at the contribution from swallows, and all the bridges along the Colorado have swallows year after year.
Yeah, we definitely, we just picked those 6 sites again just as an initial start, so that would be, yes, the next step. There's a lot of studies being done out in the Arroyo, Colorado. Anybody else? Yes.
The slide where you had the changes at the stations between years, I think it was pretty good. It was
This
pretty
one?
early. No, it was, yeah, like the tables.
Oh, okay.
Have you charted precipitation amounts at those stations?
No. And that's,
Or flow?
and well, I was trying to look it up before I came up here, but I couldn't get online. We did record flow, and this is effluent dominated, and so there was always, some flow in here. But now that would be another step in analyzing this data. But I believe 2009 was a pretty dry year. Anybody else? All right, thank you.